This is 1-6 compound inequalities. A compound inequality is more than one inequality put together on a graph or solving it. And so we're trying to find all the solutions that will work. So here's an example that I have graphed right here, this one right here. I have a number line, and notice you have an open circle here at -3, right there at -3, and it's going to the left. Well, what that means is x is anything less than -3, less than -3. It does not include -3. The open circle means it does not include -3. So it could be like -3.5, -4, -5, -7 and 1/3, or something like that. So anything to the left of -3. So x is less than -3. On this one over here, this is x is greater or equal to 2. And so it could equal 2, but it's all the numbers that are greater or equal to 2. So 2.1, 3.7, 9.97. I mean, anything greater or equal to 2 is x. And so the final, the way we would write this is x is less than -3 or x is greater or equal to 2. So x can be anything to the left of the line or to the right of that. It cannot be anything in between. So x is somewhere in that description. It's kind of like if I said the price of something, a suit jacket, is in this price range, or it's in this price range. That's what that is, that word or. It's one of those two areas. Or my age is somewhere above this or below this. You're just kind of giving a description of where x might be using the word or. All right, so let's look at another example. So here I have a graph that's drawn together, and notice that I have a closed circle at -4 and an open circle at 2. And notice it's connected in between. In the textbook, it actually draws the line in between them. So x is somewhere in between those 2 points. It does include -4 because you have a closed circle. It does not include 2. So x could be anything in between there. So look at specifically this one. Okay, your mind should think about what this kind of graph means. Okay, you don't have to necessarily do all this work, but this is what your mind should say. So this part of the graph right here, right there, is basically saying, hey, x is greater or equal to -4. X is greater or equal to -4. So it could be -3, -2 point something, -1. +1. I mean, it could be anything greater that or equal to -4. Now, this one right here is an open circle at 2, and again, it's going toward the left. So this really is an open circle at 2 going to the left, and the way we would say that is x is less than 2. So anything less than 2. So it could be 1, it could be 1/3, it could be 0, it could be -1. So anything less than 2. Now, one thing I did want to point out, this right here is the exact same thing. X is greater or equal to -4. So if I switched everything around, you still pronounce your x first. And notice the inequality is opening up toward the x, and so it's still opening up toward the x. So this literally is written the exact same way. Again, normally we pronounce our x's first. So you would say x is greater or equal to -4. So the same thing here. This is x is greater or equal to -4. So let's put this together, because what we want is one description for this. This is one description of where x is. X is in between those two values. It also includes -4. So the way that we say this, again, x is in between those two values. So x is still less than 2. And x is greater or equal to -4. So it's still this same description. You're writing this combined with this. You're kind of just pushing the two. You're kind of just pushing those two together. So here you have x is less than 2. Here you have x is greater or equal to -4. This is a compound inequality. It's saying x is in between those two values. Again, it does include -4. It does not include 2. All right, so if we had a solving and graphing problem, so a problem all the way from the very beginning. So we're going to solve it like normal. We're going to add 7, solve it like an equation. So 5x is less than 20, divide both sides by 5, and x is less than 4. Now to solve this one, negative minus 3 minus 3, we get negative 4x is greater than 8. Divide both sides by negative 4. Remember, when you divide by a negative, it changes the inequality. Okay, so you got to remember that. Whenever you multiply or divide by a negative, it changes the inequality. So think about what these are. You have to think about what this is on a number line. So if I had a number line, x is less than 4. So less than 4, open circle, less than 4. So anything less than 4. Now think about this one. So x is less than negative 2. So here's negative 2, x is less than that. So what we want to do is write one graph down here, one graph that entails all of these numbers, one graph that entails all of these numbers. So think about where these numbers are. You got 0, you got 2, you got 4, you got negative 2, and you got negative 4. So again, this is x is less than 4. So we're talking about right here. We're talking about right there. So x is less than 4. So it's all the numbers less than 4. This is x is less than negative 2. So again, we're talking about a number that's right here, and it's all the numbers less than negative 2. Well, one graph that encompasses all of them, that describes all the possible x values, is this one right here, the one that I have graphed already. So again, you really have this right here, but what you don't want to do is have, what you want is one graph that encompasses every single x possible. So this last thing we don't need. This one graph, x is less than 4, notice the arrows were going in the same direction. So you want the one that encompasses both numbers. Okay, so this one right here encompasses, everything that this one showed, everything that that one showed, this one encompasses as well. So because this one keeps going on forever, all the things to do that. So again, you do not need this one at all, just this one, it encompasses it. So you got to literally think of little graphs. You got to think of this graph, what does it entail, what does this entail, and think of one graph all together that entails all of them, that combines all of them. So this is all the x values, the solutions that will fit both of these inequalities. And let's look at one more. So again, this is a compound inequality. If you go back to where what I did earlier, when you put them together, so this literally is two different inequalities put together. So this literally is negative 12, 7x plus 9, and then you got 7x plus 9, plus they're going to go 16. So this literally is two different inequalities pushed together. So imagine me just pushing these two blue equations, taking this and taking these and kind of just pushing them together, and then you end up with that same thing. So it literally is two separate inequalities, and then you're going to solve them both. So go to minus 9, get negative 21, divide both sides by 7. Now remember, the way we pronounce that, you always pronounce your x's first. So x goes first, and notice the inequality is opening up toward the x. So we would actually pronounce this x is greater or equal to negative 3. And again, imagine what that line looks like. X is greater, here's 0, here's negative 3, here's 3. X is greater or equal to negative 3. Greater or equal to. All right, so let's look at this one. Minus 9. Divide by 7. X is less than or equal to 1. So on this one, again, this is just a little, you should always think of what that graph looks like. X is less than or equal to 1. So notice this one is a closed circle and it's going toward the right. This one's a closed circle, it's going to the left at 1. This one's at negative 3. So we're going to make a combined number line. Remember, you want you don't want to turn in two different number lines. You want one number line that encompasses all of these x's. All of these x's. All right, so again, this is x is greater or equal to -3. Notice we have a closed circle at -3, and it's greater than, it's going that direction. This is x is less than or equal to 1, so it's a closed circle at 1, it's less than. So notice x is somewhere, they meet, x is somewhere in between that. So, I mean, if I had to, you don't shade this, but again, in one sense, x is in between those 2 points. It could actually include 1, it could actually include -3. So x is somewhere in between there. And it's kind of like, I guess a good scenario would be like if I said my age, I'm above 50 years old, and I'm less than 60. So I'm somewhere in that decade of 50 to 60 years old, and I'm somewhere in between that. Well, that's what x is. X is somewhere in between those. Again, it could be fractions, could be decimals, could be 0, -1, -2, could be -3, could be +1, but it's somewhere in that range. That's what x is looking for. Again, you're trying to graph one solution or one display of all the possible solutions for x.